To man, the most important body in space is the sun, producer of thermonuclear energy. It provides him with light and heat, and is the ultimate source of nearly all the energy he receives on this planet. Similar to most matter in space, the sun is a giant ball of plasma, or gas, composed of charged particles. Observation of the sun is limited to the solar atmosphere, of which the surface or visible layer of the sun is included. It is within this atmosphere that solar activities occur, resulting in interesting phenomena or unusual occurrences. We find that the sun's surface is mottled in appearance and is marked by dark patches called sunspots. These spots appear as whirlpools of hot gas, which originated in the interior of the sun and are influenced by strong magnetic fields. As the gas rises from below, it expands and cools and appears dark in contrast to the surrounding environment. Sunspots appear continuously, but about every 11 years they are more pronounced. The spots come and go, and their existence varies from a few days for small spots to about 100 days for the larger ones. Some of the gases ejected from sunspots become solar prominences. These are the huge flame-shaped masses of hot gas that shoot out thousands of miles from the sun. Large prominences are found in the vicinity of sunspots, and their wildly fluctuating streamers are apparently controlled by the magnetic fields originating in the sunspot regions. Eruptive outbursts of hot electrically charged gases, called solar flares, also occur when magnetic activity makes sudden changes around a sunspot. These flares are visible as brilliant flecks of light which suddenly appear on the solar surface. The energy produced by the magnetic activity from these flares causes countless electrically charged particles to be shot out from the sun and carried by the solar wind to the Earth's atmosphere. The solar wind is an electrically conductive gas that streams continually out from the atmosphere of the sun. As the solar wind flows by the Earth, its tremendous amount of energy shapes and distorts the magnetic field. It compresses the magnetic field on the sunlit side of the Earth, while it extends the magnetic field lines on the opposite side. This fluctuating magnetic field, called the magnetosphere, is that region in space surrounding the Earth which contains zones of trapped radiation with a high intensity of electrically charged particles. Most important of the zones to consider for safe space travel is the Van Allen belt, which was discovered by an early orbiting satellite. The belt consists of large donut-shaped formations of charged particles in the topmost layer of the Earth's atmosphere. It is through the influence of the sun that this topmost layer, or ionosphere, is formed. Composed of electrically charged gas, the layer is mainly caused by solar flare radiation, which drives off electrons from the atoms of the gases, leaving the atoms with positive charges. The electrified air of the ionosphere reflects radio waves back to Earth at various angles, depending upon the wavelengths transmitted. The shorter the wavelength, the more they can penetrate before they are reflected back to Earth. Very short wavelengths are never reflected and continue on into space. Solar activity is also responsible for the auroras, those varicolored lights visible in the upper atmosphere. High-speed particles from solar flare activity collide with the atoms of oxygen and nitrogen in the Earth's ionosphere to form ions, or electrically charged atoms. These ions then combine with electrons to give off tiny amounts of radiation in the form of light, producing the aurora borealis, or northern lights in the northern hemisphere, and the aurora australis in the southern hemisphere. Another phenomenon is the reflection of sunlight from millions of dust particles within and beyond our solar system. Called zodiacal light, we see it as a faint elliptical disk of light around the sun after evening twilight or before morning twilight. The intensity of the reflection is dependent upon the density of the interplanetary dust and the size of the particles. An eclipse of the sun is the most spectacular of eclipses. This occurs when the moon passes between the earth and the sun and cuts off the light of the sun from the earth. When the moon serves as a shield during a solar eclipse, a wealth of information can be obtained from observations of the outer atmosphere of the sun and the zodiacal light reflections. Most celestial bodies are influenced to some degree by the gravitational action of others. For Earth, it is the gravitational pull of the sun and the moon that raises the tides, with the moon exerting more than twice the influence of the sun. We can observe this phenomenon, this lifting force of attraction in the rise and fall of the surface of oceans and seas. The tide occurs twice in each period of approximately 24 hours. Continued study of the sun and its influence is essential to understanding life on Earth. Orbiting satellites are now providing new information on the various phenomena which occur. The knowledge gained may well determine man's place in his universe.